right, welcome to lesson 1.5, limits at infinity. So this is where we are with your asynchronous lesson. If you haven't done the quiz corrections from yesterday, make sure to do so, and I'll see you live again tomorrow. Okay, so the concept of limit at infinity is what happens to y when x gets infinitely large, right? As x is going all the way to the right, what's happening to the y value? Same thing with negative infinity. As x is going all the way to the left, what's happening to the y value? And our notation is like it's been, just limit as x approaches infinity, and limit as x approaches negative infinity. Okay, let's look at some graphs to see it visually. So, we're looking at this parabola. The limit as x approaches negative infinity means if we trace it all the way to the left, what's happening to the y value? And you see it's going up to infinity. And like I said, if the limit's infinity or negative infinity, you also could say the limit does not exist because, right, it's not bounded, it's going infinite. Either one's acceptable. I'm pretty sure Delta Math is going to say DNE for this one, but on the exam you could say either one. Limit to positive infinities, as we go all the way to the right, you can see the graph is still going to infinity. Or again, you can say DNE. Okay, look at this next example. As we're going to negative infinity, so all the way to the left, you can see the graph is going, the y value is going all the way up to infinity. As you go to the right, to positive infinity, you can see though the graph is going down to negative infinity. So that'd be, again, you could say DNE for either of these. Okay, let's look at the next examples. Okay, so this one, as x is approaching negative infinity, so if we go all the way to the left, you can see the y value is leveling off at 0. This is known as a horizontal asymptote. And as you go all the way to the right, again, you can see it's leveling off at 3. Right, as I said, these are horizontal asymptotes. We'll get into that much more tomorrow. You should be somewhat familiar from Algebra 2. Okay, this graph, this is a sine curve. As you can see, a sine curve goes, right, it's a wave. It goes up and down, oscillates between -1 and 1. So the limit to negative infinity, it's just going to go like this forever and ever. So it's not going to actually approach any one number. So we would say that the limit does not exist. Again, because it's going up and down, it's not approaching anything specific. Same with as x goes to positive infinity. We'd say the limit does not exist. That says DNE. Okay. This is a cosine graph. Same thing. It's just a wave that goes up and down, so the limit does not exist as you go to infinity or to negative or positive infinity. All right, and lastly, we've got this graph here. Now this is also oscillating between up and down, but if you notice, as you go to negative infinity, the curves are getting closer and closer and closer to 1. So it actually is going to have a limit. The limit is 1 because those waves are narrowing, are converging to 1. If you go to positive infinity, the same thing is happening, but at 0. Okay, in this last example, as you go all the way to the left to negative infinity, the curve just keeps going down and down and down to negative infinity. And as you go to the right, the graph is leveling off at 5. There's a horizontal asymptote there. Okay, so go ahead and try to check your understandings in the Nearpod. You do the problem on the draw it, either type it or write it, and then check your answers on the next slide. That way you'll know if you got it, and feel free to reach out if you have any questions. All right.